Wow, it's like 7:14 already, and the 3rd of April. I was up till 5 last night reading about the universe, and I would just want to understand, um, among other things, our place, the history of our galaxy in terms of the universe. And that took a bit of time and a lot of reading. For example, if I read about galaxy structures, the universe, the Great Wall, then I would go on to talk about um, some astronomical survey. Then I read about the redshift of all these galaxies, and I do a hyperlink on Wikipedia to inflation to the grand unified epoch. And like from there, I might have to read about grand unified theory and the link in quantum mechanics and relativity. That leads on to read about the Planck scale and quantum loop gravity. Then maybe I go to a hyperlink of spin networks and gauge theory. Then differential manifolds. And to get your head around something in quantum mechanics, you got to pick at a lot of mathematics. Am I still recording? But in the meantime, I'm supposed to be doing a paper for physiotherapy. I'm presenting on Monday. It's a bit loud. I'm presenting a paper on Monday about ACBT, basically a way to get people to cough and shift and clear secretions like phlegm. Basically, they breathe deep, then they huff and they cough. It's not rocket science. So instead of doing any preparation for that, that's a huff, teaching kids how to. It bores me senseless. I spent 7 hours reading Cosmology, and if you look at two galaxies, that's just a picture there. Our closest galaxy is Andromeda. It's 2.5 light years away. One day it's going to crash into the Milky Way, our galaxy. Here's M104. That's a Sombrero galaxy. It's beautiful. It's from the Hubble website. Our galaxy, the Milky Way, has some 100 to 200 billion stars. There's 30 galaxies nearby called the Local Group. The Local Group is part of the Pegasus group with some 50 galaxies. And then the Virgo supercluster group, which has like 2,000 galaxies, and that's all part of some other bigger structure. But in terms of why galaxies have their shapes, I don't have a nice picture, but if you imagine this here is a picture of two spiral galaxies interacting, like how do they get their shape? How do galaxies get their tails like this? Well, it's simple. This is a simulation done by the University of Toronto. This is Andromeda, this is the Milky Way. They're going to crash into each other in a few billion years' time. And you can see how galaxies get their shapes. Most people don't know this. You can see they tear each other apart. And each second is like 225 million years. So that's most of the galaxy is empty space, so you can assume that stars don't crash into each other. More collision simulations. That was done with a supercomputer in Toronto called McKinsey with 512 processors. They used 300 million particles to simulate these galaxy interactions. And it's a really nice DVD that you can buy. It's called Gravititis. It's got 9 films with nice music. That was a bit of a tangent. Oh yeah, you can see lots of galaxies interacting. Our galaxy makes a rotation in 225 million years. We're about 25,000 light years from the center of our galaxy, where there's presumed to be a black hole. So you can assume that when our galaxy made 12 rotations, that's how long it took for life to evolve. So while these galaxies are crashing into each other, you can have stars that are main sequence stars that are producing planets that are creating life the whole time while galaxies are interacting. And if you look at our local group, for example, the galaxies are buzzing. Let's go. We want to see like 30, 40 galaxies interacting. It'll be like our local group. I'm on the wrong chapter. That's lots of galaxies buzzing around. Newtonian stuff. Lots of galaxies. The resolution's not good on my phone. Lots of galaxies interacting. I want to see them like bumblebees, like 30, 40. I just can't find that sequence. Oh, I suck. So in our local group of 30 galaxies, this is flying through. Anyway, I also did some reading on the credit crunch and economics because I want to do a 250-word essay for Amplify Trading. And if I write the essay that they select, then I get sponsored to do a master's in finance and trading, which is worth like £6,000. Oh, there's a fly through our galaxy, I believe. passing through the center zone, and then out again. Now you really want to see the buzz about galaxies interacting. And here we go. This is like a hive of galaxies. Each second is 225 million years. And there's a super kind of galaxy in the middle. There's little peripheral galaxies that are all flying around each other. They all are influenced by gravity and shred each other and merge together and buzz around each other. Like right here, for example, in superclusters, galaxies have high speeds of like 1,000 kilometers per second. In groups, galaxies only have speeds like 150 kilometers per second. So maybe you can see the more galaxies, the faster their velocities are, because they accelerate around each other. So that's a simulation of how galaxies crash together. And who would have ever guessed that galaxies really kind of evolve in such a way? We won't be around when Andromeda crashes into the Milky Way. So maybe I'll try to write my paper on physiotherapy breathing techniques tomorrow. But so far I'd rather read economics and cosmology. Oh, so the local group, here we go. Be important to have a one opener as the pointer. Here's the Andromeda galaxy, and here's the Milky Way. That's, I think, 2.5 million light years. And you can see that all these galaxies, these 30 in our local group, they're all buzzing around each other and behaving much the same as the simulation is. And the same dynamics in galaxy interactions in stock markets, you know, like emergent behaviors, chaos theory, there's stochastic processes, there's connections between everything. So, say bye to Andromeda, and say goodbye to the Sombrero galaxy.